Okay, so in the previous video, we talked about the idea of using Makefiles and Make utility to sort of automate the process of compilation for our small C++ project, right? However, in this video, we're going to talk about sort of using advanced features of Make utility or Makefiles in general. And just like the tradition of all these video series, we're going to start with sort of defining the problem first. Let's take a look at our Makefile. This Makefile works completely fine. It's simplistic. It works, but there's a slight issue with that. Let's take a look at this thing. So we have a G++ command right here, and then we have another G++ command. If you take a look at here, there's three G++ commands right there, right? And if you scale this project, if you have 100 libraries, then you're gonna have end up with 100 lines of G++, which is repetitive patterns, right? So what if I scale this project and one day I come to you and say, hey, I don't want to use G++ compiler anymore. That's boring. I figured out that, for example, Intel compiler is much better than GCC. Then you say, oh, not a big deal. I just say I replace this with ICPC, which is the Intel compiler. ICPC, you know that this is not the way to do it, right? Because you're manually basically substituting every instance of G++ with ICPC. So you can say, hey, I'm not that dumb. I can use %s in Vim and then substitute G++ with, for example, ICPC. Then I can do it globally, and then with one hit or return key, every instance of G++ is going to be substituted with that. This is sort of cheating, right? What if I told you, for example, hey, I want to add hundreds of other include directories, like I want to do this, I want to do this. So you get the idea, right? So you know that you cannot rely on, for example, other third-party text editor sort of features to circumvent or to solve an issue which is related to Make exactly. So there needs to be a solution within the boundaries of Make utility. So you sort of now get the idea what the problem might be when we scale this project and we want to make changes, for example, to the compiler, or if you want to add, for example, external libraries, you want to add stuff, then you don't want to go manually there and then change every G++ command there. So what is the solution? The solution is very simple. You can, the same way that you're using variables, for example, in Bash, you can use variables in Makefiles as well. So let's say I have a variable called cxx, which is assigned with G++. Then I can do this simple pattern that I had before, but instead of placing ICPC right there, I can say use this cxx variable and use it globally, and no for this one, yes for the rest. So take a look at this one. If I want to change my compiler, I come to the header, and I say ICPC, and I save it, I say make. Of course, I don't have the Intel compiler. It's gonna complain about that. But this is the way to do it. It's very simple now. With one line change from ICPC to G++, basically now you can compile everything, right? But you don't need to change anything here. The same way sort of associated to those compilation recipes for a C++ project, you can also define CXX flags. You can also define LD flags. These are the linker flags. You can also define LD libs. You can, the same way for directories as well. For example, you can have a bin directory. You can have a lib directory. You can have a include directory. How do we fill these? So this can be the standard, which is C++11, and it can have also the include statement with, -i, and then include. And then here you can have -L, and then you give the library, and then here the small letter, Runge-Kutta, same way as before. Nothing is basically fancy here. You can also type here include. And now if you save this one, if you come back to your instructions, now you have a bunch of variables defined here, and now you can use them. I can get rid of this thing here, and the same way I can get rid of the standard as well. And I can come back here, and instead I can sort of expand CXX flags. Just as simple as that. Or I can smartly do it with sort of a -L, and then do this lib, and then I can substitute it with LD flags, for example. Just like that. Then I say no for this one, yes for this one. The same way I can do, for example, like ld libs, and then I can change this one into -l Runge-Kutta, and I can do this thing, no for this one, yes for this one. Same way I can do this for directories as well. I can say this one can be my bin directory, and instead of this, I can have, for example, dot and then bin, and I'm gonna do this, no for this one, yes for this one, yes for this one. I can do the same way and substitute the lib directory for every instances of .lib, no for this one, no for this one, yes, and yes for these. And I can do the same for, you get the idea, you can do the same for include directory as well. So now take a look at no for this one, no for this one, yes, 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 and yes for this one. Now take a look at this one. It doesn't look like anymore anything near or similar to what we had in the beginning, right? So now we have converted it to sort of a very unique way looking by using these custom variables. What else can we do? Take a look at this thing. So we have a.out here, and then we have our target is also a.out. So what we could do is to basically go down here, then we can remove this thing, and then we can use a special automated variable. This category of variables are called automated variables in the context of make. So this @ variable basically is gonna expand itself into the target that you have. The same way I have librungekutta.so as my target, so I can remove this thing, I can say @. And I can runge-kutta.o, I can do the same right here, and I can put @ right here as well. What else can I do? Take a look at this. I have a dependency runge-kutta.o, and then there is another special sort of variable, which is, I don't know, smaller or greater sign, whatever that is, but it should be this way. So this expands into the first element of your dependency list. So if you have 10 of the elements right here, it's going to expand only into the first one, which is runge-kutta.o. What else can I do? Of course, I can go down here instead of a.out. I can use also patterns that I can use in my shell. Like I can use a star here to basically, oops, I didn't mean to do that. I can use a star right here to say, and basically I want to get rid of all the .so or all the dynamic libraries in my project. This is good when we have like we scale this project, and when we have hundreds of dynamic libraries with one single command, everything is going to get basically deleted. Of course, we need to test this thing to see that whether it works. Now, if I say make, of course, everything is going to work just as before. Now, if I say make clean, it's going to clean everything for me. And if I say make update Runge-Kutta, the same way it's going to work, and then only update my my shared library. So isn't that very nice looking right now? If I want to change anything, I just go to my header file, and then I add stuff, and all the subsequent changes are going to be right here. Now let's talk about another issue. This issue is when make, so this is the behavior of make when it faces an error. For example, let's say I have updated my library, so there is nothing in my binary right now, but in my lib directory, there exists a .so librungekutta, right? What if I want to if I say make clean, I want to get rid of this .so, I want to get rid of the object file, and also the binary. If I say make clean right now, take a look at this. Make says, hey, error 1, the code is 1, and then it says no such file or directory. If I check my lib directory, I see still this thing is here, but I know that if I go to my Makefile, clean basically consists of 3 commands, or 3 basically remove instances, right? But when make faces an error, it basically closes the terminal that it was basically all those instructions were being called upon, and then comes back to the main terminal, and it gives you in a standard error the error that it is facing basically, but it just stops from continuing to build your project or to execute the instructions that you have basically. This can also happen, for example, if I go to my Makefile again, and let's say I don't want to have only one recipe. I want to also, for example, make the bin directory myself. I want to make sure that the bin directory exists. If I say make, the same way the 2 G++ commands are going to get executed, but then make directory, because the directory exists, it says file exists. and then it comes back, the final G++ command, which is for compilation of main.cpp, is not going to get executed. Isn't that ridiculous? Because we don't want our build process of our project to be crippled. We want make to continue to basically execute whatever we want. So now in this specific instance, we can use the -p flag, of course, right here to basically force make to not care about. Not forcing make, we are using -p flag of make directory, which doesn't throw the error if the directory exists. So now if you say make, of course, the last sort of command or syntax is going to get also executed. But this issue still persists. If I call make clean again, we're only going to see this thing, one error. How can we resolve that one? So this is why it's always a good idea to have a dash in front of your sort of commands, just like that. If you have a dash in front of your commands, and if now you say make clean, now you see 3 instances of errors. But each time you see ignored, ignored, and ignored. Do we have another workaround? Can we? But this is so good, right? Now make is not sort of stupid, sort of just leave everything and then leave the building process of your project crippled, and then come back and cry and complain about an error that is dubious, and you don't care about that error at all because this file doesn't exist, or this file already exists, or things of that nature. Another thing you can do is, of course, compile, not compile, but execute make with -i or -i, which basically stands for ignore errors. Like you can say ignore errors and then clean, the same effect is happening. Or you can expand it like ignore errors. This is the same way. It's the same thing, but you're doing it with the full name. So -i is just a shorthand for this one. So yeah, so as I said, it's also a good idea to have a dash command when you have these sort of stupid commands that remove something, or you know that it might happen that the shell returns an error. You don't want make to stop from continuing to execute other sort of commands. So here you go. Now you have converted your Makefile into an advanced looking sort of Makefile, which if you scale your project, you basically need to change everything in the header, which is at the top of this thing, and then all the subsequent changes are going to get applied right here. So I hope you learned something from this video, and hope to see you in the next one.